In the first several problems, we're asked to find the square roots of the numbers. And in some of them it's pretty obvious, in some of them you may have some of your square roots memorized. But I'm going to show you a method as well to discover square roots using the fundamental theorem of arithmetic, or basically prime factoring the way we have been in class. So for a number like 16, it's pretty obvious that 16 is 4 times 4, and we know that whenever we have a number times itself, whenever we're looking for the square root of 16, it's the same thing as saying the square root of 4 times 4, 4 times 4. And whenever we have a number times itself underneath a radical, then that number is the square root of that number is the principal square root. Remember, the radical is the principal square root. It's asking for the principal square root, and by principal square root we mean the positive, the non-negative square root. So in this case, the square root is the square root of 16 is 4, but we're asked to find the square roots of 16. Remember that 4 times 4 is 16, but also negative 4 times 4 is negative 4 is 16. And the way we write that, since the radical means it requires us to do the principal square root, we also need to find what the opposite, or the negative square root of 16 is. In this case, the negative square root of 16 is the opposite of 4, or negative 4. So when we're asked to find the square roots, our answer should be 4 and negative 4. Those are our square roots of 16. Number 2 says find the square roots of 225. Now you may not have the factors of 225 memorized, and that's okay. We don't need to memorize all of our factors as long as we know how to prime factor. So let's take 225 and let's prime factor that. Now remember, when we're prime factoring, we're looking for the smallest prime number that can evenly divide into 225. Well, we'll start with the smallest prime that we know, 2, and because the number's not even, 2's not going to work. So the next prime that we know is 3, and we know that 2 plus 2 plus 5 is 9, so yes, this number is divisible by 3. So we're going to go ahead and do that. We'll go with 3, and 225 divided by 3 is, let's see, 3 goes into 22 7 times with a remainder of 1. 3 goes into 15 5 times. And then we go again. Smallest prime number that goes into 75, not 2 because it's not even. 5 does go into 75, but it's not the smallest prime number. 7 plus 5 is 12, so that means it is divisible by 3. Remember, as long as I add the digits together and that sum is divisible by 3, then my number is divisible by 3. So 75 divided by 3 is 25. And we know, well, this makes it easy, we know that 25 is 5 times 5, and 5 is only divisible by 5, so we're done at this point. So 225 is 3 times 3 times 5 times 5. And when we see that, we notice that we have this number here is a square. The square root is 3. And this number here is also a square, and the square root is 5. Right? If I were to take the square root of that number, the square root of 3 times 3, the principal square root is 3. And the square root of 5 times 5 is 5. So the square roots of 225 are 3 times 5, or 15, and remember, we need both the principal square root and the negative square root for our answer. So for number 2, our answer is 15 and negative 15. We could do the same thing with 144. If you don't have it memorized, you should, because it's a pretty common number. 144 is divisible by 2, and that leaves us with 72. That's divisible by 2, and that leaves us with 36. That's divisible by 2, and that leaves us with 18. That's divisible by 2, and that leaves us with 9. That's divisible by 3, and that leaves us with 3. And so we have, for 144, we have 2 squared, and here we have 2 squared. Well, 2 squared is 4, so that implies 4. So really, 144 is 4 squared times 3 squared. And if I take the square root of that, the square root of 4 squared is 4, the square root of 3 squared is 3, so it'll be plus or minus 12 for the square root of 144. 9 should be pretty easy. 9 is 3 times 3, so the square roots are plus or minus 3. And you can write your answer as plus or minus 3, or you can write it as 4 and negative 4, 15 and negative 15. Either of these are acceptable answers. Well, 400 is kind of a big number, so it'll be a little long and awkward to go through the whole thing here. But I notice that 400 has a 4 here. And I know that 4 is 2 times 2. And since it's in the hundreds, I have 2 zeros. So let's say that 400 is 20 times 20, right? Because the 2 zeros from the tens place there, 2 times 2 is 4. So that's 400. Therefore, the square root of 400 is plus or minus 20. And again, 81 should be obvious. It'll be 9 and negative 9. Those are the square roots. Alright, those are the square roots of 81. Okay, so that should be fairly obvious for 1 through 6 there. Now let's take a look at 9 through 22. So this one is just really, these questions are really just questions about vocabulary. Remember, this is the radical, and the radical tells you, in this case, because our index is not stated, we assume that our index is 2. So the radical tells us the kind of root we're looking for. We could have a radical that says the third root of 27, which would be the cubed root of 37, or 27 rather, or 27 to the 1/3 power, which in this case would be 3. And remember that for an odd index, for an odd root, I can take the odd root of a negative number, because negative 3, if I were to expand that out, if I were to say negative 3 to the 3rd power is negative 3 times negative 3 times negative 3, that would be a positive 9 times a negative 3, and then a positive times a negative is a negative. 9 times 3 is 27. So when it comes to odd roots, cubed roots, fifth roots, and upwards, we can have negative numbers under the radicals. With even roots, like our second root or our square, we cannot have negative numbers under the radicals. The answer is not real. So if the symbol itself is called the radical, and it's telling you to give me the principal square root of whatever is underneath the radical, then what is underneath the radical is called the radicand. So in this case, y squared plus 16 is the radicand. In this case, p squared minus 10 is the radicand, right? P squared minus 10, that's your radicand. The expression x over y minus 1, that's your radicand, and so on. Okay? So those are the answers to the questions on page 507 and numbers 1 through 6, 19 through 22.